Life on Mars? Could it be possible? For as long as humans have stared upward into the night sky, Mars has glowed like a burning ember, close enough to ignite curiosity, yet distant enough to remain mysterious. It has been called a desert, a wasteland, a dead world. But beneath all those labels lies one ancient, unshakable question. Is there life on Mars, or could there ever have been? That question has guided astronomers and fueled dreams for centuries in the search for answers. The potential for alien life. And today it invites us on a journey across time and imagination, deep into the story of a world that may not be as silent as it seems. Believe it or not, Earth and Mars are not as different as many people think. Mars, often referred to as an alien planet, shares several striking similarities with Earth, which is why scientists often think of Mars as Earth's smaller, colder sibling. One of the most remarkable similarities is the length of a day between the two planets. A solar day on Mars is 24 hours, 37 minutes, and 25 seconds. That's only about 40 minutes longer than Earth. Both planets also experience seasons. Earth's axis is tilted at 23.5 degrees, while Mars's tilt is 25 degrees, making their seasonal patterns surprisingly alike. As a result, Mars has spring, summer, autumn, and winter just as Earth does, though each Martian season lasts far longer because Mars takes almost twice as long to orbit the Sun. Fascinating, right? With a day-night cycle and seasons so close to our own, Mars becomes one of the easiest planets for humans to adapt to. Mars also shares several Earth-like weather patterns. Since it rotates at a similar speed, it has winds, weather changes, and even cloud formations. Although its atmosphere is much thinner, the dynamics feel familiar. Dust storms instead of rainstorms, thin wisps of clouds instead of thick ones, yet still recognizable as weather. Geologically, Mars also mirrors Earth in many ways. Its surface includes mountains, canyons, volcanoes, deserts, and dunes, and also shows clear evidence of ancient rivers, lakes, and even possible ocean shorelines from billions of years ago, making parts of its landscape eerily similar to Earth's desert regions today. Both planets have polar ice caps that grow and shrink with the seasons. Earth's caps are mostly water ice, while Mars's are a mix of water ice and frozen carbon dioxide. Despite the difference, the seasonal expansion and retreat of these caps act in a very familiar way. Chemically, Mars contains the essential building blocks that we have here on Earth needed for life: carbon, hydrogen, oxygen, nitrogen, and organic molecules, which have been detected by NASA's Curiosity and Perseverance rovers. While Mars is far harsher, these shared ingredients deepen the possibility that life may once have existed there, or could if not already. Even more intriguing is the discovery of minerals that form only in the presence of water, as well as chemical energy sources that certain microbes on Earth rely on to survive in extreme environments. Together, these clues suggest that Mars not only had the right ingredients, but may have also had the right conditions, a combination that keeps the door to Martian life wide open. Another often overlooked clue lies in Mars's underground chemistry. Scientists have discovered that Martian rocks contain perchlorates, salts that can lower the freezing point of water. On Earth, these same salts allow microbes to survive in places where liquid water shouldn't exist at all, such as the hyper-dry Atacama Desert. On Mars, perchlorates may allow salty liquid water to briefly form even in extreme cold, creating short-lived but potentially life-friendly environments beneath the surface. Exactly the kind of hidden niches where microbes could endure. So what about gravity? Mars is far smaller than Earth, but its gravity remains surprisingly practical. At about 38% of Earth's gravity, it is strong enough for humans to walk, work, and move naturally, just lighter and more agile. This could make lifting heavy equipment easier and reduce strain on structures, while still allowing the human body to function without the disorientation experienced in microgravity. However, long-term exposure may affect bones and muscles, meaning future explorers would need exercise and medical countermeasures to stay healthy. Even so, Mars's gravity strikes a rare balance, low enough to ease exploration, yet strong enough to support long-term human presence. Now let's turn our attention to the growing excitement among scientists about Mars's lava tubes. immense underground tunnels carved out billions of years ago by flowing magma. When the surface of these lava rivers cooled and hardened, the molten rock beneath continued to flow, leaving behind vast hollow corridors once the magma drained away. These lava tubes could be enormous, some potentially wide enough to house entire city blocks and long enough to stretch for miles beneath the surface. What makes these structures so compelling is not just their size, but their stability. Unlike the fragile surface, which is constantly bombarded by radiation, micrometeorites, and extreme temperature swings, lava tubes offer a naturally protected environment. Inside, temperatures remain far more constant, shielded from the brutal cold of Martian nights and the heat of daytime. Thick layers of rock overhead block harmful cosmic radiation, one of the greatest threats to both life and human explorers on Mars. Even more intriguing is the discovery that some of these lava tubes contain water ice. Orbital imaging has revealed collapsed skylights, natural openings into the tunnels, where bright patches of ice can be seen clinging to shaded walls. This ice could provide a critical resource: water for drinking, oxygen for breathing, and hydrogen for fuel. For life past or present, this combination of shelter, stability, and water makes lava tubes one of the most promising environments on the planet. Looking ahead, these same tunnels could play a vital role in humanity's future on Mars. Rather than building habitats exposed on the surface, astronauts could one day seal off sections of lava tubes and turn them into ready-made shelters. With natural protection already in place, these underground spaces could dramatically reduce the need for heavy shielding and construction materials. In many ways, Mars's lava tubes are not just geological curiosities. They may be the key to both discovering life and sustaining it, whether microbial or human, on the red planet. Altogether, all of these similarities make Mars the most Earth-like planet in our solar system. They are also the reasons Mars is at the heart of our search for ancient life and future human exploration. However, despite its many similarities, Mars experiences a phenomenon unlike anything on Earth. Planet-wide dust storms so vast they can wrap around the entire globe and last for months at a time. These storms begin as small regional events, but because Mars's atmosphere is thin and its gravity is weaker, winds can lift fine dust particles high into the sky, where they absorb sunlight and heat the air. This warming accelerates the winds even further, creating a runaway effect that allows a single storm to grow until the planet itself seems to vanish beneath a shroud of red haze. During these global storms, sunlight can be reduced to a dim twilight across the entire surface. Temperatures shift, winds intensify, and the landscape is constantly reshaped. For life on the surface, these conditions would be brutal. But beneath the ground, the story may be very different. As dust is carried across the planet, it redistributes minerals, salts, and chemically active compounds, effectively mixing the Martian surface on a global scale. Over millions of years, this slow but persistent cycling could concentrate useful chemical ingredients in certain underground regions. On our own planet, entire communities of life exist in caves, deep rock layers, and hydrothermal systems, completely cut off from sunlight. These organisms feed on chemical energy released by interactions between water and rock. Mars's dust storms, by constantly refreshing and redistributing reactive materials, may have helped sustain similar subsurface environments in the past, and could even be doing so today. Rather than signaling a lifeless world, Mars's endless storms may be part of the very process that kept hidden life alive. Makes you think, doesn't it? Another intriguing detail is Mars's radiation history. While the surface is bombarded with radiation today, ancient Mars was far better protected. This means life may have had millions of years to emerge and evolve before conditions worsened. And even now, just a few meters of soil is enough to shield organisms from harmful radiation, making the subsurface one of the most promising locations in the search for life. Mars also teaches us something vital about Earth's future. The red planet shows what can happen when a world loses its magnetic field and atmosphere. By studying how Mars changed and how life may have adapted or vanished, we gain insight into how fragile planetary habitability can be. In that sense, Mars is not just a destination, it's a warning, a lesson, and possibly a mirror of what Earth could one day become if we're not careful. So let's go back, not to the very beginning, but to a moment in Mars's long history that changed everything. Mars was not always the quiet, frozen desert we know today. Billions of years ago, before Earth had even settled into its familiar shape, Mars may have been a thriving water world. Imagine warm rain falling across valleys, rivers winding through canyons, and oceans stretching farther than the eye could see. Evidence from orbiters and rovers paints this picture clearly. Dry riverbeds, minerals forged in water, layered sediments, and vast ancient shorelines. Water is the greatest storyteller life has, and on Mars its traces are written everywhere. But something dramatic happened. Over millions of years, Mars began to lose its protective magnetic field. Without that magnetic shield, the solar wind was able to slam directly into the atmosphere, stripping it away over time, tearing its atmosphere away piece by piece, leaving the planet exposed and vulnerable to radiation. Radiation from the sun and high-energy cosmic rays from deep space. As the air thinned, the temperatures dropped, the oceans evaporated, and the rivers froze into silence. Mars transformed from a potentially life-supporting world into the frozen desert we see today. Yet the end of the surface environment does not necessarily mean the end of life. On Earth, microbes can live in all kinds of environments and thrive in boiling heat, freezing cold, toxic water, and total darkness. If life ever began on Mars, even something microscopic, it may have found ways to endure the planet's long winter underground. Deep beneath the Martian crust, where radiation cannot reach and where pockets of ancient groundwater may still linger, there could be hidden havens. Caverns shielded from the harsh surface might hold conditions stable enough for microbes to survive. When our rovers dig into Martian rock, they're not just gathering dust. They're searching for organic molecules in ancient fossilized cells, chemical clues of alien metabolism, and the faint signatures of biological processes. And every so often, Mars reveals something surprising. Methane, a gas that on Earth often points to life flickers in the Martian atmosphere. It appears and disappears in puzzling seasonal cycles, almost like a slow, steady breath. It could be geological, but it could also be biological. This is one of the many space mysteries that keep scientists awake at night. An even stranger possibility comes from Earth itself. In 1996, scientists found a Martian meteorite in Antarctica containing tiny structures that resembled fossilized microbes. While still debated, the idea unlocked a thrilling question. Could life travel between planets? We know meteorites from Mars reach Earth. We know some microbes survive the vacuum of space. If early Mars was warm and alive, could it have cast biological seeds toward Earth? Could our earliest ancestors have come from Mars? If so, we are not just explorers of another world. We might be returning to our birthplace. The search for life on Mars is more than scientific curiosity. It forces us to consider our place in the universe. Are we alone? Are we unusual? Or is life a natural consequence of chemistry, destined to appear wherever water, time, and energy meet? If we find life twice in one solar system, in two neighboring worlds, then the universe may be overflowing with living planets. Every star we see could host a dozen thriving worlds. Every galaxy could be bursting with ecosystems we cannot yet imagine. And perhaps the most exciting part of all is that we may not be that far from finding out. When it comes to reaching Mars, the technology is no longer the barrier it once was. Robotic missions have successfully made the journey many times, and the same basic propulsion methods can carry humans as well. A crewed mission would likely take 6 to 9 months each way, depending on planetary alignment. Space agencies like NASA, alongside private companies such as SpaceX, are actively developing the spacecraft and life support systems needed to sustain humans on such a long journey. The greatest challenges aren't the distance itself, but survival. Astronauts would need protection from radiation, reliable supplies of food and water, medical care far from Earth, and ways to cope with long periods of weightlessness and isolation. There is also the challenge of landing safely on Mars and supporting a crew once they arrive, knowing there is no quick return if something goes wrong. Despite these hurdles, plans for human missions to Mars are already taking shape, with targets often set for the 2030s. In other words, humans can go to Mars, And it's likely that within our lifetime, someone will take that first step onto the red planet. As we bring this to a close, remember this. Mars is bursting with clues that life could exist there. It once had rivers and lakes. It still carries the essential chemicals for life. Organic molecules hide in its rocks. Methane flickers mysteriously through its air. And liquid water may still flow deep below the surface. So we return to the question, is there life on Mars? Was there ever? Or could there possibly be? The real answer is we simply don't know yet. Not for sure, but we stand at the edge of discovery. Mars is waiting, its past etched in stone, and its present wrapped in mystery. And one day soon, someone will announce what humanity has been longing to hear. But until that day comes, the red planet keeps its secrets, but not forever. If you enjoyed this deep dive into the mysteries of life on Mars, don't forget to like, subscribe, and turn on notifications so you never miss out on our next adventure into the unknown. What do you think about the possibility of life on Mars? Share your ideas and theories in the comments below. Let's keep the conversation going and explore more of the cosmos together. Thanks for watching, Orbit Crew. We'll see you on the next mission.